We're going through built-in types in Swift. So type this, var a string, :string equals double quote hello playground double quote. This creates a string variable from a literal. Swift string literals are declared with double quotes surrounding the content. Swift strings support non-ASCII characters directly in the literals. This is especially great if you prefer to develop in a language which uses lots of non-ASCII characters, or even emoji. Here's a string with a clubs character. That, it turns out, is pretty useful, even in English. Swift also supports many non-ASCII characters in variable names, like this. And don't get me wrong, I love creating custom mathematical operators and using correct Unicode symbols, but I spend more time searching through a Unicode table to find the right character than if I had just typed out the name. Besides, some Unicode characters are difficult to read, so I recommend that you only use non-ASCII characters where it greatly clarifies the purpose of the name, and it's easy for a developer to read and type. Strings can be concatenated using the plus or plus equal operators. Here I construct the string one piece at a time. I can't append other types like ints to strings. But I think you'll find you don't want to do that much because you can place an expression directly into the string literal. I put parentheses around a Swift expression with a backslash before it. This is called string interpolation, and it looks similar to escaping. It's mostly useful in debugging. Now let's dive into collections in Swift. We'll start with arrays. Try this. Var integers : open square bracket int close square bracket equals open square bracket close square bracket. This is an array of integers. The type of the element goes inside the square brackets, and the empty square brackets initialize an empty array. Yes, even collections are type safe in Swift. If you're moving from Objective-C or JavaScript, you're going to love type safe arrays. The type of the elements can be as precise or as loose as you want. Maybe what we really needed is an array of booleans. And if we really do need to put anything in there, we can. But the truth is, that's not terribly useful because there aren't any functions that can operate on an any, besides explicitly testing what type it really is. What we should do is pick a type which specifically provides the properties and functions we'll need when accessing the elements in the array, even if that type is a protocol, which we'll cover a lot later. An array can be randomly accessed by the index, which must be an int. The index goes in square brackets, called a subscript, similar to C-based languages. Swift also includes the very popular for-in syntax. The compiler inferred the type of an integer based on the type of the array of integers. I could specify it explicitly, as I suggested earlier. We'll talk about powerful functional programming methods like map and filter in another lesson. Next, let's create a dictionary. A dictionary is Swift's name for a C++ map or a JavaScript associative array. Open square bracket, key type name, : value type name, close square brackets, and the empty literal is open square bracket, : close square bracket. Just like declaring an array with square brackets and the value type names, so a dictionary is declared with the type name of its keys, followed by a colon, and then the type name of the values. Here, I've created an empty dictionary of string keys which map to int values. By including the colon in the empty dictionary, I've distinguished it from an empty array. So let's insert a value into the dictionary. I can iterate over them. Notice that I've put parentheses around a key, a value. This is called a tuple. We'll deal with those much later. But when I try to pull an exact value out, I have to account for the possibility that it's not in there. The question mark turns the type into an optional, which means there may or may not be an int. This is where your ears should perk up because the compiler is actually keeping track of whether the values are missing or might be missing. The universal value, which means there is no value, is nil. I can initialize an optional with nil or with a value. For an integer optional, being nil does not mean 0. A nil value for an integer optional means there is no int. We'll talk more about optional values later, but for now, I want you to remember that it's perfectly safe to discover that a value is missing from a dictionary. But if I tried to access a value in an array that was out of bounds, the app would crash. Instead, we should always explicitly check the count property of an array before explicitly randomly accessing elements. Today we learned about strings, how to create them, combine them, and place other values in them. We learned about non-ASCII characters in literals and symbol names. We learned about two types of collections, arrays and dictionaries, both of which are type safe in Swift. We learned that Swift has a convention for representing the lack of a value called an optional. Meaningful text, types, and even the lack of a value? Now that's Swift.